Hey guys, today we're going to talk about acids and bases. You should have done a reading and watched a few videos on this so far, so hopefully this is a little bit of a review. Grab this Cornell note sheet or grab a blank one, and then you can write along when I go through the examples. So the first thing is acids, and for this Cornell notes I have not put the questions in here, so you are going to have to come up with a question. It's probably going to be pretty basic, but the answer is written here to that question. So come up with a question that is answered about acids here. So an acid is something that tastes sour. So lemons or batteries, anything that really has a sour taste or even has just a touch of a sour taste. We normally think of acids as something that's going to burn you or melt your skin or do something really scary, but as you saw from the Coke can video, the acids, strong acids and strong bases can both do a lot of damage. So an acid tastes sour. The pH is between 1 and 6.9. It turns pink in a cabbage juice indicator. So the indicator is probably going to be a purple, and then when you put it in an acid, it will turn pink. And examples of acids: apple juice, anything with a lot of sugar too, is probably going to be an acid. Apple juice, lemon juice, soda. Soda is super bad. I just went to the dentist and they have a poster about all the different pops and how acidic they are in your teeth, and I'm pretty sure it was Pepsi was 2 point something, and that is super acidic and hard on your teeth. And that's why after you drink pop, you should rinse your mouth out with water just so you can get some of that acid off of your teeth, or you're brushing and flossing to get all of that off, because your bacteria love it. Alright, so sodas, candies, tea, coffee, orange. This isn't in your notes, but I think this is important to write on there. So all acids have more hydrogen ions, and hydrogen, you know, is an element on the periodic table, and it only has one proton, one neutron, one electron, and when it's by itself, it's an ion, and that just means it has a positive charge. So all acids have more hydrogens or H's in them. Examples of acids: we've got some batteries here, a bunch of different kinds, but even the battery that's in your car, all of these have acids that are a pH of 1, which is a super strong acid. A Coke is 2.5, and a Pepsi was less than that. So I guess Coke wins there because it's not as acidic and hurtful to your teeth. Orange juice has a pH of 3.3. So you can see these are increasing here. And then the last one, coffee, is a pH of 2. And coffee or tea, all of this has acid in it. So going from strongest to weakest, it goes from 1 is very, very strong, and then the orange juice is 3.3, is a little bit weaker, but it's still not super weak. I'd say that one's just a straight up acid. So stomach acid is kind of scary because it does have, I mean, Coke, you put that on your skin, it doesn't burn you, but stomach acid has a pH of basically the same as Coke. It's between 2 and 3. So this is still considered a strong acid, and this is how your body digests all the food and breaks it up, along with the muscles contracting and breaking it down mechanically. But the acid is the chemical part of the digestive process. So when you eat, sometimes when you eat a lot of spicy food that is acidic, it will decrease this pH to maybe a pH of 1 to 2, and that is an upset stomach. So when your stomach just really, really hurts, you can feel it burn, you get a little bit of acid reflux, that's when this is actually jumping up and it's hitting the bottom of your esophagus and it burns. That's acid reflux. So when you have that, or if you've heard your parents have that, they normally take something that is called an antacid. An ant is the opposite of whatever it is. So this is the opposite of an acid, but antacids actually have a pH of a 5 to 6. So that is still considered an acid, but it is a lot weaker acid than your stomach acid. So when you take an antacid, it actually brings the pH level up from like a 1 to 2 probably back to normal, which is a 2 or 3. So these are still an acid, even though it's called an antacid. Tums, the Alka-Seltzers, Rolaids, Pepcid AC. These other ones I've never heard of, but maybe you've heard them at your house. Next one, you have to come up with a question again that talks about the notes that are here. So a neutral substance is a substance that is not acidic or basic. It has the pH of 7 and it turns purple, or it stays purple when you put a cabbage juice indicator in it, or the litmus paper that you probably read about, but those have different colors. It's either red or blue. I can't remember because I only really use cabbage juice indicator. So again, write this down here somewhere. It has an equal number of hydrogen ions and hydroxide ions. So hydroxide is just an O and an H, and when it's just that, it has a negative charge, and that's why it's called an ion. So if you look at that and you add an H plus an OH minus, okay, that's 2 H's and 1 oxygen. That is water. So this is talking about just straight water, is like basically the only neutral substance. So this is distilled water. There's no minerals in there. There's no fluorine. There's nothing else in there. No particles at all. It's just distilled. That has a pH of straight 7. So an acid is anything up to a 7. So I'd say 6.999999. That is an acid. And this is hydroxide, OH. It has a negative charge, and this is a hydrogen. It has a plus charge. So when they come together, they form a neutral molecule, water. Even these bottled waters here, you would think, oh, that's probably distilled water, but they're not. They have things added to them, and it depends on the different kind of water that you drink, but they can have pHs of probably 6 up to 8. And you would just think that this is straight spring water and it's super good and it's just like normal water and it's even better than my tap water. But these are actually, you don't even know. These could just be filled from somebody else's tap and shipped and bottled to you. Bases. Again, come up with a question here. Bases, these taste bitter. So basically, the base is exact opposite of an acid. They taste bitter. They feel slippery. They have a pH of 7.1 up to 14. And when you put it in the cabbage juice indicator, it turns green. So this is a lot of the household cleaners that you use, or soap. A lot of food is basic, but then when you cook it, it turns acidic the more and more processed and cooked it is. So in examples of bases, mouthwashes, detergent, so any type of detergent, even if it has water added to it, it is still basic. That's what helps get out all of the stains and clean your laundry. Cleaning supplies. And again, these have more hydroxide ions, so the OH minus. And that just means when you put it in solution that the OH actually moves away from the H, and there's going to be more of these. So examples, bleach This is super strong. This has a pH of 12. Any bath soap or hand soap that you use is probably going to be a 10. And avocados, again, a lot of food are between 8 and 9. Baking soda is a 9. So the weakest one here, weakest base, strongest base. So when we move on the pH scale, we go from strong to weak to neutral, weak to strong, because we're going from pH of 1 all the way to 14. And that's what this is about, the pH scale. It means the power of hydrogen, how much hydrogen is in that solution. And it goes from strong acid to weak acid to neutral, and then it goes back from base. But it doesn't just have a strong base, it starts with a weak base up to strong. So the two very ends are the strongest, and this is a 1, this is a 14. So in that Coke can video, I'm pretty sure they did sulfuric acid and sodium hydroxide, which is a super strong base. So when you look at some of these pH scales, you might have already come across this, they have the word alkali instead of base. A base is the thing that neutralizes an acid. So when I add an acid and a base, it forms water and a salt. That's called a neutralization reaction. Alkaline is talking about what happens to the molecules when you put them in water if they can dissolve in water. They're basically used interchangeably. So I'm always going to say base. I don't really say alkali, but you might recognize that word when you were working on the periodic table and you had alkali metals. And bases are almost always metals, some sort of metal molecule. And here is a pH scale. I'm sure you have already looked at these. The acid, again, hydrochloric acid. Then we got like milk, we got straight water, blood, and then drain cleaner, which is super, super basic and is scary. Like, you don't want to be playing around with that. And the last picture I have is this. I just think this really shows the H+, the hydrogen ions, and the hydroxide ions. And these are base. So when you have an acid, they have a lot more H's. And when you have a base, they have a lot more OH's. And then when they are perfectly equal, the number of hydrogens equal the number of hydroxides, that is straight up water. And that is this neutral place right here. So I hope that makes sense. You can write your summary, rewatch this, look up some pH scales, and see how you can find this stuff in your everyday life.